Hi friends, welcome to our channel. Let's have a look at today's daily challenge problem. Maximize happiness of selected children. So in this video, we're going to explain a method, roughly like greedy method, but what the focus will be on the analysis or the reasoning. So here we are given an array called happiness of length n and a positive integer k. K will be less than or equal to m, right? So we want to choose k children from this n children in k turns. So in each turn, so when we select a children, then the happiness value of all the children that have not been selected till now will be decreased by 1. So note that the happiness value cannot become negative and it gets decremented only if it's positive. So we want to return the maximum sum of the happiness value of the selected children we can achieve by selecting k of them. So there are 3 examples here. And in the first example, so this is very special because here the values are large enough. For example, if you choose the largest 2, so if each of them decremented by 1, so it's still positive. So actually if you choose 3 first, then 2, 1 will become 1, 0. So you choose 1 again, so you get 4, right? So that's basically you choose the largest possible. So actually the total decrement amount in this case will be a constant, depends on key, right? So in the example 2, we can only choose 1, then all the others become 0, so we cannot accumulate scores or happiness. So in the third example, we for sure take the largest one, right? So here are the constraints. The happiness are strictly positive, and the k is less than or equal to n, greater than or equal to 0. So this is then consistency assumption. So with that said, actually we are ready to, I would say we are ready to analyze the logic. Then writing the code should be rather straightforward. So here we want to claim that we shall greedily choose the current largest one. And then in this way, once we meet a 0 after continuous decrement, so we shall stop. So this way we will get the largest result. So here we can consider 2 cases to digest this point. First, if the k largest values are so large that all of them would be non-negative after a decrement of k minus 1, right? Because you have k round, the first round will not decrement. So then in this case, the final value actually is the sum of the k largest values. So minus, so 0 plus 1 plus k minus 1. So this one is, it's very easy to compute, which is k times k minus 1 divided by 2. So there's no further thoughts needed. And then the other case is that if in the decrement procedure, there will be some value from the happiness array arriving at 0 after some step, say I0 step, right? So the decrement will be I0 minus 1, right? But in this case, I0 will be less than k, I would say, because the k equals k case is covered by the first scenario. So, and then in this case, we hope I0 can be as small as possible, because we just need to sum the first I0 element, then minus this one, right? So we want to quickly get I0. So here I can demonstrate with 2 examples, because here you can do some mathematical proof, but here the coding, if we do the proof, that's detours too far. So here I give an example for this case, right? For the first one, I guess we don't need to seek further thoughts. So here, if we choose 4, the length is also 4, right? So the scenario 1 is we choose the largest, always choose the largest. So we first pick 5, then the 4, 2, 2 becomes 3, 1, 1, and then we can pick the 3, so we left. The 1, 1 will be 0, 0. Then in this case, we get 8. And then another scenario, so if you want to choose the smaller one, which you might think, oh, I can first pick those, and then pick the largest one, so they have enough to decrement. But this way, we decrement too much. So we want to decrement as small as possible. For example, if we choose the smallest one, say 2, then we get 5, 4, 2 becomes 4, 3, 1. Then we pick the smallest one, say 1. So always left the larger ones, which can be decrements with less, with strong ability to be non greater than or equal to 0, right? So we pick 1, then we get 3, 2, because 4, 3 will become 3, 2. Then we choose 2 in this case. 3 becomes 2. And then we can pick 2 again. But in this scenario, we do all 4 picks, right? Because here k is 4. But the total is 7. Therefore, always you pick the largest one and then do the decrement, you get the largest value. So once you realize this one, so I guess this is, the coding is just nothing but a, say, for loop or while loop with a break condition. Let's do it. So let's initialize a result variable. But here, I guess it's better to do a sorting. Or you can use heap, but here I don't think we need to resort to heap. So here we do a sort, reverse equals true, right? So here, well, let's use a for I in range, say, k, right? Then the first round you decrement by 0. So let's see, check the current round, hi minus I, right? So this is the exact one. So if temp is greater than 0, so we are going to increment by temp. Otherwise, so we should stop. But here we can break, let's see, and then we do a return, right? Return the result. Actually, here you can also directly return results if you like. This is also the case. Then you can try to run. It passes the 3 cases. So now let's look at the generic case. Yeah, it passes all the cases. So from this daily challenge, I would say if you are very familiar with the syntax of the language, so for this problem, it's mainly the reasoning that leads you to a quick solution or valid solution. So with that said, I guess that's it for the current video. Thank you for watching.